lesson 20. Here we come. You realize that when we're finished today with lesson 20, we only have, oh dear, we only have 100 more lessons to go. Doesn't that make you feel great? Hey, Mom, I'm so happy. I only have 100 more lessons to do in Saxon 7-6. Oh, honey, come here. I'm going to do the dishes today, and I'm going to mop the floor. I'm going to change the baby's diaper. If we don't have a baby, I'm going to find a baby and change its diaper. I'm going to hug my grandfather. If I don't have a grandfather, I'm going to find the grandfather and change his, hug him. I'm going to go tar the roof. You know, what a great day this is. Okay, so we'll have fun doing 20 today. All right. Now, this is weird. You're going to like this, though, this greatest common factor thing. You probably heard of this term before, the greatest common factor. All right? The factors of 20 and 30, you tell me. What are the factors of 20? Obviously, 1 and 20, right? Okay, what else? 2 and 10, right? All right, one more set. 4 and 5. Okay, all right. How about 30? What are the factors of 30? Obviously, 1 and 30. Okay, what else? 3 and 10. What else? 2 and 15. It's an even number. Don't forget 2. And then, of course, we know 5 and 6. Okay, so look at those, and you go, let's look at all the factors. What are common among them? Obviously, 1, that's common. You know, we can do that. Okay, let's see. 20 is not. That's not. Oh, 2 is. There's a 2. Is 6 in both of them? No, it's not. Oh, 5 is in both of them. So there's our 5. Is 15 in both? Nope, that's not it. Is 3 in both of them? No, it's not it either. 4 is not in there. Oh, there's a 10. Okay. So you can look at this and go, well, the common factors of 20 and 30 are 2, 10, and 5, right? But what's the biggest one? 10, obviously. The greatest common factor, that's the definition of the greatest common factor. Greatest, we all know that means biggest, right? Common means it's in both of them, or it might be 3 of them. We'll do something like 3 of them. A factor is a number that divides evenly exactly into a greater number or the same number. And that's it. Which one's the biggest one? It's 10. There we go. That's the greatest common factor of 20 and 30. There you go. Okay. That's, again, if you want to write that down, it's the biggest factor that will divide evenly into a group of numbers. That's all there is to it. You can pause it if you want to. Okay. All right. Let's find the GCF of 24 and 30. In other words, don't just like, rotely go, whatever. What are we asking here? We're asking for the biggest number that goes into 24 and 30. Right? That's what we're doing. Okay. Now there's a way of doing this that is quite fun. Now, you can do this. I'll show you 2 ways. You can list the common factors of 24 and 30, or just all the factors. So 24 will be 1 and 24. I'm not going to bother with that. 1 and 24 and 1 and 30, forget that. Okay. We can do, let's say, 2 and 12, right? 3 and 8, right? Those are factors of 24. Oh, 6 and 4 too, right? Remember those? Okay. And 30, we'll say 2 and 15. We'll say 3 and 10, right? And then 5 and 6. Okay, I think that's it. All right. You tell me, is 12 isn't common, right? 15 isn't common, so ditch those. 8 is also not common, and 4 is not common either, right? In fact, 10 is not common either. So we have, wait a second, 5 isn't either, because 5 is not going to 21. So we have 3 and 6, and we have 3 and 6. Those are common ones, right? So obviously the greater one is 6. Okay, all right. Now here's another way of doing this. I want to show you. Make sure you understand how to do this, all right? So you might want to copy this down, pause it, make sure you understand it. I'm sure you guys have probably all heard of the factor tree thing. You ever heard of that before? Like the factor tree? If you go 24, you go, oh, I'm going to factor this out into 2, numbers and keep going until you can't go anymore. And you can start with 8 and 3 if you want. You can start with 2 and 12. You can start with 6 and 4. It doesn't matter. Just don't do 24 and 1. You don't need to bother to do that. Well, why don't we just try 6 and 4? Whatever. Now, can you factor 6 anymore? Sure you can. You got a 2 and you got a 3. I'm going to circle those to tell me that I can't factor those anymore. And 4, of course, you can factor into 2 and 2. So there's your list of factors. 2, 2, 2, and 3, right? Because 2 times 2 times 2 is 8, times 3 is 24. We'll just put it that way. All right? 30, let's do the same exact thing. In fact, you pause it right now. Do exactly the same thing. Doesn't matter if you start with 2 and 15, 3 and 10, or 5 and 6. Go ahead and pause it right now and do it. Okay. Let's say you started with, 3 and 10, whatever. Well, 3, there's nothing else you can do, right? Just circle it. You can't go anywhere else. 10 is 2 and 5, and both of those are prime numbers too. You can't do anything else with that. Now, look, for example, let's say you did, instead of 30, you did 3 and 10. You did, 2 and 15. That's okay. That 2, you can't go anywhere with that, right? 15, you can go, oh, that's 3 times 5. Well, look, you got 2, 3, and 5. Look, 2, 3, and 5. You get the same thing. Doesn't matter where you start. Okay, so look at this. Here is what these multiply to give you. 2 times 3 times 5, right? That's 30, and this part is 24, right? Okay, so which one of these are common with each other? If you look at this, you go, oh, wait, both of these guys have a 2. There's a 2 there and a 2 there. So I'm going to put that up there, 2. I'm going to multiply it by something else. Excuse me. There's another 2. Does that have, oh, there's no other 2. So I just get rid of that. Is there another 2? Oh, no, there's no other 2 there either. Okay. There's a 3. Oh, there's a 3. Yeah. There's a 3, so that'll be 3. And 5, and there's no 5 over there. It's not common. So all you do is you pick out the ones that are common. 2 times 3 is 6. That's the biggest number that goes into 24 and 30, which is just what we said a few minutes ago, right? There you go. That's the method of doing it. If you go, oh, I can't think of it. There you go. That'll always work. In fact, it'll work with 3 numbers, because at some point they're going to give you 3 numbers and go, find the greatest common factor of these 3 numbers. And you're looking at them and go, ugh, I don't know what in the world to do. And you'll know what to do now. Okay, so let's try it again. So find the greatest common factor of 9, 12, and 33. And you might look at that and go, you might be able to do this in your head if you want. Let's say your factor tree. You're going to go, okay, that's going to be 3 and 3. 3 times 3. 12, that's going to be, I don't know, I could do 6 and 2. I could do 3 and 4. I don't know. I'll just do 6 and 2, or 2 and 6, or whatever order you want to do it in. Oop, that's a prime number. Can't do that anymore. 6 is 2 times 3. That's as far as I can go on that one. 33, you should know your times tables, and that's 3 times 11. And the question is, which one is common among all 3 of those? Okay, you go 11, obviously, there's no 11s there. 2, nope, there's no 2, there's no 2s in all of these. Hey, wait, here's a 3, this 3, there's a 3, there's a 3. Okay, so at least 1 3, and then there's another 3, and you go, oh, well, no, they don't have any other matching 3s to match that. So that's it. What's that 3 mean? That means that's the biggest number that will fit evenly into 9, 12, and 33, and that's all there is to it. That's your greatest common factor. There you go. That's your method. Okay. Try the practice set. You can eyeball it. You can do that factor tree method. You can list out the factors, whatever you want to do. Find some way that works for you and is really fast. And if you're kind of torn between 2, go to the factor tree method maybe, and try to do as much as you can in your head and figure out the answer. And then, all right, let's try it. Go ahead and pause it and do A. Okay, obviously A would be 5, right? Okay, all right, pause it and try B. 18 and 27 for B would be 9. 9 goes into both of those. Just very, very quickly. You can skip this if you know what you're doing. But if you did this, for example, 18 and 27, I can't figure out what it is or whatever. You'd go 18 is, 6 times 3. You could have done 9 times 2. It doesn't matter. That's going to be 3 there and 2 there. So you would say, okay, that's a 3, 2, 9. 27, that's 9 times 3. Can't do anything else with that. 9 is 3 times 3. Okay, so you go, okay, 3 is common right there. So I'm going to go, 3 is there. Okay, times what? There's a 3 and there's another 3. Okay, that's good, 3. And then 2 and 3, there's nothing common there. That's it. 3 times 3 is 9. That's the method. There's what you do. Okay, pause it and try C. Okay, C, using the same thing as 6. 6 goes into both of those. Pause it and try D. Well, look at there, 6 again, right? Okay, now you can do 3 factor trees if you want to and figure out the greatest common factor using that method, all right? Pause it and try E. Okay, obviously that's going to be 5 again, right? 5 goes in both those. Pause it and try F. You probably recognize that was 10, which is fine. You can still do the same thing. Pause it and try G. Biggest number that goes in 12 and 15. 12 is 3 times 2 times 2. If you wanted to write it that way, let's say you did a factor tree. You would end up with 12 is 3 times, I'm just going to put, instead of putting 4, I'm going to put 2 times 2, right? 15 would be 5 times 3. Well, look at these. What's common? The 3 is common, and that's it. Which means the biggest number that will go into 12 and 15 is 3. Okay, last one, try H. Now you might have said 10 for H, and that is incorrect. What was the biggest number that goes into 20, 40, and 60? Well, you might already know the answer, that's fine. If not, let me just show you very quickly. 20, 40, 60. I'm going to do this kind of rapidly, okay? So 20, I'm just going to write the prime numbers. There's going to be 2 times 10. I won't write 10 because that's not a prime number. 10 is 2 times 5. So that's what 20 is, prime factors. 40, I'm going to write this again. For 40 will be 2. Okay, so 2 times 20. I'm not going to write 20 though. 20 is 2 times 10, so I'll write 2 again. I'm not going to write 10. I'll write 2 times 5. 60, and if you wanted to, you could write 2 again, or 6 times 10, or 15 times 4, or whatever. I'm just going to write 2 times 30, but I won't write 30 because 30 is not a prime number. 30 is, let's say, 10 times 3. Instead of writing 10, I'll write 2 times 5. And those are all prime numbers, right? Well, you tell me, what's common among all of those? Well, there's a 2, and a 2. Got it. Good. Okay? And, oh, look at this. There's another 2, and another 2, right? There's 2 2s. There's oh, look, they all have a 5, they have a 5, and there's a 5. Okay, so that's it. But, that's all we can do, because this has an extra 2, that has a 3 that the others don't have, so we stop right there. That's 4. 4 times 5 is 20. 20 is the biggest number that goes into 20, 40, and 60. That method will never fail you if you do it right. So anyway, all right, have a great day. After today, you'll be finished with 20 lessons and problem sets. That's 600 problems you will have done, not including the warm-ups and the practice problems. So have a great day. See you next time.